We know that D is P AP inverse and so if I solve for A in this, I'll get that A is P D P inverse, and now if I take A to the 10, I'm going to get PD P inverse to the 10, and let me write that. Let me spell it out because it looks like it's completely useless. But if I write this matrix next to itself a bunch of times, what I notice is that I end up with P and P inverse right next to each other. So these two would cancel, these two would cancel, and that's awesome because I end up with only one P and one P inverse left. This first one will stay, and then I'll get a bunch of D's. And then the last P inverse would stay as well. So if I put it all together, I get P, D to the 10, P inverse. Now we've already computed D to the 10, and it wasn't hard because D's diagonal, you just take the powers of the diagonal entries. So now we're ready to compute A to the 10. It's P, actually let me write what P is, don't remember. So I get 1 on 5, 1, 1, 1 on 5, 0, 0, 1, 0, 1. Then D to the 10 we said was 1, 1, 1024. And then P inverse, I computed this on the side. I got 0, 5, 0, 1, 4, minus 1, 0, minus 5, 1. Alright, so you can multiply them in any order you wish. Let me do the second product first. Alright, so I'm going to get 0, I'm going to get 5, and I'm going to get 0. I'm going to get 1, 4, and minus 1, 0. Now it's the only one that I have to actually compute is this one. I'll get 22, 10, 12, 1, 5. So I get minus 5,020 and then 1,024. Alright, so I have one last product to compute. I get 1 plus 4 minus 5,120. I get minus 1 plus 1,023. 24. It'll be 1,023. And when I compute it, this is going to be 0. This will be 1. This will be 0. This will be 0. It'll be 5 minus 5,120. And the final one will be 1,024. Alright, so we get 1 minus 5, 115, 1023, 0, 1, 0, 0 minus 5, 115, 1,024. There you are. Now, this method works for any n, and it doesn't get much worse. The only issue is that these entries might get much bigger, or might be fraction if your n is negative. But any integer would work. So let's give a formula for any n. So d to the n, d for me was this matrix. So this to the n, and we know that we just take the nth power of all the diagonal entries. So that's d to the n. It doesn't simplify much nicer than this. And then a to the n, as we just argued over there, is p d to the n p inverse. So I'm going to get p is 1/5 1 1, 1/5 0 0, 1 0 1. And then we have 1 minus 1 to the n, minus 2 to the n, and then the same p inverse. Alright, so we can multiply this. Let me use the same order I did on the last problem. So I'll get 0, 5, 0. And then here I'll get minus 1 to the n. 4 times minus 1 to the n, and minus 1 times minus 1 to the n, which I'll write as minus 1 to the n plus 1. Then the bottom one would be 0, minus 5 times minus 2 to the n, and then minus 2 to the n. Alright, so we multiply it out again. Here I'll get minus 1 to the n. Here I'll get 1 plus 4 times minus 1 to the n, minus 5 times minus 2 to the n, minus 1 to the n plus 1, plus minus 2 to the n. 0. 0, yep, 1, that's it. 0, pretty simple. 0 again, so 5 plus minus 5 minus 2 to the n. Minus 2 to the end.